Bine. Welcome back to Science Hub. My name is Marian, Bănică, and today we are going to talk about the role of open source software in modern and applied physics. My special guest is Cristian Presura. He is a renowned physicist. He is part of Philips Research Center in Netherlands. And welcome back to Science Hub, Cristian.
Thank you for inviting me.
Yeah, it's a great pleasure to have you as a guest today. We know that you apply physics in a very qualified research center. Tell us about yourself a bit and how do you apply physics in your daily job.
So I have a PhD in physics from the University of Groningen in the Netherlands. My specialty was optics. And then since 20 years, I'm a researcher at the Philips Research Lab in Eindhoven, now part of IPNS. And I'm basically developing software and hardware for the wellness sensors, like, for example, optical heart rate, which anybody can find in a smartwatch. It was developed by us here about more than 10 years ago.
Mm-hmm. So basically, in a few words, you are also an inventor, right? With your team.
Yeah, exactly. And then, of course, open source software, we use it. Everybody uses Python, I suppose.
Yeah.
And then for every problem we have to solve, sometimes we just look on internet. If we find something open source which is useful, we use it.
Mm-hmm. Tell us about the software development in general in a research center like in the Philips Research Center that you are part of.
Well, it certainly plays a very, very important role. I remember when I started 20 years ago in research in a private institution, the hardware part was much more present. Today, many hardware, acquisition, many hardware control is done through the software, and also a lot of analysis is done today with the software. So, in other words, during these years, I saw a transition to a more and more software-oriented research, which is based on hardware. But I was surprised that the software components can bring us, let's say, added value. And if I'm thinking right now at the revolution of AI, AI is bringing again a revolution in added value brought by the software.
Mm-hmm. So how relevant is for you the open source solution comparing to the commercial solutions in general? Which ones are more used in the research center that you are part of?
If I'm talking about research, not about, for example, physics students or physics children who learn at school. Mm-hmm. If I'm talking about research in a private institution is driven by the quality. So in other words, if you have to do a small thing and fast and you have access to open source, you do it. But if it becomes long term and you want to do good quality work, and if there is a software paid which helps you, then you try to buy that software and then make use of it. So in other words, the open source software is a good start for small things, for a quick start, but once you go further into the really development and so on, then paid-based software is probably the option of choice.
Mm-hmm. Can you tell us a few solutions that you are using? Some of them open source, some of them maybe commercial?
Well, open source, I use Python, and for example, at the same time, I use MATLAB, which is commercial. Mm-hmm. I use, for example, COMSOL, which is commercial, because it's very, very powerful. In the beginning, I used all kinds of electromagnetic simulations, which were free. But then when I went deeper and deeper into those solutions, I was not anymore satisfied with the open source software, so I switched to COMSOL, which is very, very powerful paid version of a software which does simulations.
Mm-hmm. So these are the main one. What about latex, which is also the tool that you used in order to...
Count.
No?
It doesn't count. I thought you may want to say LabVIEW, for example, from National Instrument, which does count indeed, because when you have hardware and you want to control hardware, LabVIEW is a very, very good choice. On the other hand, you may, LaTeX is for writing articles. It's not like, even not like Mathematica, you know.
Good. Can you share some examples of widely used open source software that are used in physics community? Not necessarily that you are using, maybe that you know. We have also some images on the screen in order to give some examples that are used, but maybe you can share with us other tools that you may know.
Yeah, so the point is that we can talk about software in research, but we also can talk about educational software. So there is a large, area when you go from software for research and then software for educational purposes. Because sometimes you can use software for educational purposes to do, a small, quick thing in research. I don't know what you're showing here. I'm not able to read what software it is.
There are some print screens from GNU Octave, from other tools like PhET, and also open source physics, which is a really good tool, and so on and so forth. Some of them are for simulation, some of them are for experiments.
So the point is that there is a lot of software which has to do with analysis, or a lot of software which has to do with, visualization. For example, if you want to do statistics, you may want to use the R software, which is specialized on statistics. But I never use R software because I try to understand the statistic behind. So that's why I personally use MATLAB for that kind of analysis. And of course, as usually research, you write your own routines, you reuse those routines, and so on and so forth. For these times, for example, visualizations, I use very often Mathematica because it's a quick way to visualize stuff. For controlling software, as I told you, I use LabVIEW. And that also has some part of analysis, quick analysis, which gives you some first grasp on the signals. And then for real simulations, deep simulations, I use Console.
Okay, how do you see the open source solutions in the learning process when people are just starting to understand the principles of physics, or when they want to get more in depth with the principles that are taught in the schools, even in universities?
Yeah, that's a different discussion because the point is the following, especially in physics, because as you know, probably I'm coordinating some manuals in physics. And the point is that software can be used as a tool by the teacher and by not the student, but the child who is learning. He may be 12 years old, 13 years old, 14 years old, and so on and so forth. And in physics, you would rather just do straightforward experiments with your bare hands, to feel stuff, to see it with your bare eyes. That's the best way. So in other words, in lab. But not all labs in the world and not all labs in schools around the world have the capability to have a very good, equipment. There are many schools which have no physics lab anyway. And then, indeed, then you can go to these open software tools like, for example, PhET, which gives you a way to simulate what you want to do in an experiment. And there are many ways in which you can approach that problem. For example, you can be a teacher and you teach the student a lesson, and then you give them the software and they have to solve a problem via the software. So in other words, instead of doing a real experiment, they do a simulated version of the experiment. And there are many tools available on the internet, and they are really from very early age, so simulate very simple stuff, like balls, balls moving, flying in the air and so on and so forth, or going to more complex like electromagnetic fields, simple, very, very simple electric fields, very simple magnetic fields, what happens with the two magnets and they come closer to each other. And then, of course, they go even into the real student area when you're at the student university and you want to do simulation, for example, for scattering of particles in accelerometers. And there are, fortunately, many, many tools, and the teacher can use them, and then also, under the supervision of the teacher, because it's a different discussion, how useful is for a child if he doesn't have the supervision of the teacher.
Mm-hmm. So you see a lot of applications in the learning process, much more basically than in the private research centers, right?
Yes, I see them very, very useful because in principle they are not complex. If you want to do a research tool, usually research tools are very complex and it requires a lot of development. But on the other hand, if you want to create a tool for children at school to just simulate something, you can do a Java simulation, for example. You don't have to use console, to simulate what happens with the ball when it's rolling down. Just do a Java simulation and it's good enough for the child. So in other words, it's much easier, and then that's an advantage, of course.
Mm-hmm. So in the professional research centers, basically, what you are using is mostly cooperation with software developers in order to develop for your own needs different tools that maybe are not yet on the market, right?
Not necessarily. In my particular case, I don't think I'm doing that. In my particular case, I'm just looking for the software which is on the market because that's the type of research I do. But I can imagine that if you're doing a different type of research, for example, you do image analysis, and you have a particular set of data which you want to analyze. You can say, generally speaking, medical images. And then you want to create your own tool, and then you want to have a very, very good tool for research. Then you indeed develop those tools for your own research together with software developers. I can imagine, but in my case, it didn't happen.
Mm-hmm. Can you give us some examples of tools that you are using in computational physics and simulations in general?
Well, computational physics is for me like computational optics. Mm-hmm. And I use the Zemax, for example, which is a very, very good tool. You put there lenses and you choose lenses, and it's very, very specialized. And you can use Zemax indeed to develop optics, but very, very good optics for real cameras if you want, or whatever you want. So Zemax is a very well tool for optics, which I used, but I used it very minimal because I didn't need a lot from it. The guys who really developed optics for cameras and television and whatever, they use it fully, but I didn't have to. And I remember that I also used open software in order to do that in the beginning, but then I switched to Zemax. It took me some time to learn it, and then it was also useful for me.
Mm-hmm. Let's talk about some limitations, because open source is, even if it gives you the source code, it comes also with some limitations, right? And there are some challenges associated and limitations associated with open source software in physics. Can you tell us about the limitations that you see?
Well, there is one point which I want to make for the educational software. So I'm not talking about open software for research, which again is Zemax, for example. I think it was a paid software. Open software for research, of course, it has many limitations by itself because it's not developed very, very deep. But I want to maybe discuss about open software for education purposes, because that too has limitations, and that's something which I struggle sometimes with. They try to make it simple, readable by the student and so on, but the interface is usually very, very simple. So in other words, I don't know, it doesn't really appeal to the user. You cannot do many things, but anyway, you don't want to do many things. and it's not very user-friendly, I would say. It's usually the kind of interaction you have with the software is the kind of interaction you have with a mobile application on a mobile phone. You just try to look for the menu to see what happens with the different buttons. It's not very natural. It's not the way you would interact if that would be a real experiment. If that would be a real experiment, maybe you would interact a different way. So in other words, the interface, I think, can be improved for this educational software, which to give you, in a sense, the feeling that you are really working and interfering with a real physics experiment.
Mm-hmm. You are also author of different manuals of physics. Did you encourage in your manuals the use of open source software for physics?
Yeah, for sure, because what we try to develop our manuals on the basis of experiments. So in other words, the whole philosophy is that the child should experiment himself something and then try to understand with the help of the teacher. That require, of course, much more work, that requires some kind of equipment, but if the child does that, he has a much better understanding of what physics is, rather, than somebody telling him this is physics and writing on the blackboard, and the child would have no connection to the real object. So that's why we encourage in our manuals a lot of real physics experiments. But sometimes they are difficult to be made, even if we have a lab. So sometimes what we put in the manual was a link or a QR code to PH let's put it this way, or to other websites where they have virtual experiments. So in other words, the child is encouraged to enter on the website and then do a virtual experiment, and on the basis of the virtual experiment, try to draw some conclusions. And of course, this one has disadvantages because it's virtual, but it has also advantages because with virtual experiments you can do much more. So you can have different kinds of exercises and so on and so forth.
Mm-hmm. In research in general, and maybe you can share us some of the insights from your own research. People are collaborating a lot. This is also happening in open source. How do you see the collaboration in open source software for physics?
Well, certainly today in physics, there are many groups who collaborate each other. For example, the best example is CERN in Switzerland, where you have thousands of researchers collaborating on a project. When they publish the paper, there are thousands of authors, which is something almost unimaginable. So there is certainly this collaboration. And then remember that internet actually started at CERN, because they wanted to create, to connect all the PCs from CERN in Switzerland in order to send data from one computer to another and then analyze this data. And this was the first step for the internet. So you may say that physics and collaboration in physics brought what we have today, which is the internet. And this collaboration goes on. And I can imagine, and I see that, for example, in the tools which I have with the heat hub and so on and so forth, is that there is a collaboration in the team who develops open software, but there is also a request from outside to do something. So in other words, researchers themselves ask open sources for stuff they need, and of course then there is a collaboration which it comes or if it does not come. In my case, that didn't happen because I told you I usually work with paid software, but I can imagine that happens.
Mm-hmm. Let's talk about also another very important topic in technology that it happens right now. It's the increasing use of artificial intelligence and machine learning. How do you see this in the development of the research for physics?
Well, first of all, the AI is at the moment a disruption for everybody in the field. And in disruptive, not in the negative sense, but also in the positive sense. I personally, for example, like the fact that with the new AI, you can program much faster. because sometimes you just get functions from that from the AI. Sometimes AI gives you suggestions. So programming is becoming, much faster and also affordable for people. So in other words, you don't have to learn so much nowadays in order to make a successful program, because sometimes you rely on AI tools to fill in the gap of knowledge, and then you can realize that as well. So in other words, AI helps programming, programming helps physics. A direct connection between AI and physics, I didn't see, I have to admit. I have to think about it if I saw somewhere, but I don't think I saw a direct connection, in the sense that people try to use AI, to solve physics problems, or to use AI to develop new materials, or maybe one which is successful indeed, to use AI to analyze big chunk of data, like for example astronomical data coming from the satellites. It's huge, so then you can use AI to analyze it. And also at CERN, because I mentioned CERN, where you have many collisions between particles, and they are very, very fast, and you are talking billions of whatever collisions, and you have to analyze your data, and you have to discern all data. There, for example, I know that AI is used to filter the data in the beginning, because otherwise you would have too much data and you wouldn't be able to process it. So you have to filter it right from the beginning, and they do it with the base of the AI.
Mm-hmm. How do you see the role of open source solutions in that is playing in interdisciplinary research?
Well, interdisciplinary research is basically when you have, for example, physics and medicine.
Mm-hmm.
And if you relate it to open source software here, it would be difficult for me to find the connection, because usually the teams have anyway a problem discussing with each other, because when you have a physicist and a doctor, they discuss different languages. So usually it's from the beginning something difficult you have to realize. And if you're talking, for example, about images which analyzes, so take for example medical images, and you have to draw some conclusions. Then you have a collaboration between some physicists who develop the software, because of course you have to get those images, and those images should be analyzed on basis on the hardware. That means what you measured. So there you have physicists who basically give you the images and then image analysis, and then you have the doctors who have to say something relevant about those images. So in other words, you are forced to collaborate, technical people, physicists, with the doctors and with the software people, to have these medical images, very well aligned and understood. But what is here the role of open source software? Because in my case, I didn't see really here the use of open source software, because there is such one-to-one relation. Usually have a software which you develop yourself and you keep it yourself in the company or whatever. So I'm not so sure, but I can imagine that there is a thing which could open in the future. For example, think about all these wearables and all the data which is available when you collect all the data from the wearables. You have millions of people, millions of wearables. You collect all the data, and of those people, they give permission for the data to be analyzed. If they give permission for the data to be analyzed, and the data could be analyzed on large scale using, for example, AI, using open source software. And I find cases in medical literature. For example, if you talk about the photoplethysmography signals, which are the PPG signals for coming from the optical sensors, which gives you, of course, a signal of the pulse and so on and so forth. And you will find, for example, on internet, open data. So in other words, data which was measured by the university and shared on the internet. And you may find even open source software. In other words, software which analyzes the data, and then on the basis of the analysis says something about the data. But if you go into the collaboration with the doctors, you may find here and there some articles, but I don't think it's very often in open source community.
But what about AI? Do you think that is going to help people to collaborate much easier on long term in interdisciplinary research?
I think I'm afraid I have to say no. Because for AI, in order to be successful, you need large training data sets. So in other words, the companies who are going to win this AI competition are the companies who have access to large data sets. That's why you are talking about big companies like Google, like Apple, maybe Samsung or whatever. So these companies have access to big data sets, and once they have access, they try to keep the data closed for themselves. They wouldn't share it with the rest of the world because it's their big advantage. The data is their big asset, and on basis of the data, they can develop AI, and that would be their advantage to the competition. So, in other words, you have right from the beginning a framework which doesn't encourage, collaboration in AI, but it's on the reverse. It says to companies, if you are a big company, it's much better to keep the data for yourself because then you have an advantage to the competition.
Mm-hmm. How do you see, or what are the tools that you are most excited that are developed in the last period of time?
Well, for certainly the AI tools, the AI tools are a surprise for everybody. Even if you take, for example, ChatGPT, which you may say, well, it's a dummy because it writes something which you found on the internet and then rewrites it in a form. And I can imagine that in other fields, people use ChatGPT for text writing. For research, it's not much use text writing because you have to do real research. It's not about writing, it's about the real research. But on the other hand, tools like that, like the artificial intelligence, can help you in research to find sources of information much faster, and also make connections between different research fields much faster. So in other words, these tools of AI can be used in searching in a much more effective way than we do searching right now, even on the databases. So here probably is going to be a big influence of AI on the way searching for research is done.
Mm-hmm. What do you see that is going to be the future of IoT?
Internet of Things?
Yes.
It didn't fly, did it? It didn't really fly. I remember 20 years ago, people were discussing about, objects in your kitchen. You'd have your fridge, you'd have all the equipment connected on the internet, and then you'd ask the fridge, what do you have at home for me? And then the fridge would tell you immediately what it has, so that you can think of preparing food or something. There was a big attraction, the Internet of Things, maybe not 20 years ago, 15 years ago, but since 10 years ago, things didn't really fly. The only thing which maybe happened was this webcam, which became very, very popular. In other words, everybody at home has some cameras and then supervising the house or whatever. But for the rest, our things are not connected to internet, except our mobile phone. It didn't fly. And if you ask me why it didn't fly because there is no real use, is it? I don't know. I don't think there is another answer.
Yeah, but do you know that the research that I'm involved in, it is heavily based on IoT sensors and combined with robotics. And basically, I'm automating all the repetitive tasks with robots, and I'm getting data from the IoT sensors. And from my point of view, I'm considering that there is a big importance of getting all the data in a single place and getting and analyzing all of them and taking decisions based on data, which is impossible without IoT sensors.
Yes, but I think if you go in specific areas, indeed, you may find advantages. But it seems to me that it's not for everybody. I mean, I'm thinking more of the wellness domain. Mm-hmm. Because, for example, if you are talking about medical domain, where you have, for example, patients, in the hospital, There may be very useful. Maybe that's different, a different area, different approach.
Can you share us? Can you share with us some important places from where we can find more about different tools that can help us to maybe to start a career in research or in the educational part in physics?
Well, the point is that if you want to start a career research in physics, that's the point I discuss with all the students in general, is that you have to understand that you have to learn mathematics. So in other words, if you start physics, learn mathematics. Yeah. And if you want to start a research in physics, there are many tools available, there are many paths available, but it's really the straightforward way. In other words, you go to university, you are a good student, you learn mathematics and physics, and you try to be one of the best students in class. And then the doors are open for you to do research in the labs around the world. And then it really depends only where is your passion. So it depends on your passion. If you, for example, like astronomy and astrophysics, then this is your passion, and then you go into that direction. If you think of materials, yes. If you think of neuroscience, go into that direction. So I don't think there is a different way than it was before, like 20 years ago. In other words, learn very good at university, be good in math, and then try to be one of the best, and then you can do research.
Also, can you tell us some examples from your daily activity where you are using different open source solutions?
Well, I have to think if I used it actually the last week or some kind of open source software. I mean, besides Python, which, yeah, that's daily kind of.
No Linux?
No Linux. No. I didn't use Linux, I think, for years.
Yeah? Okay.
Yeah. So I'm afraid I cannot say that. Even, for example, when I do stuff, easy stuff, I go to Wolfram Alpha. I'm not using any more Mathematica. The easy stuff I get from the website, which is free, open, Wolfram Alpha, I think I did some calculations 2 days ago.
Let's take a conclusion about this. What do you think is the impact of using different tools in improving the quality of the research that you are doing?
Well, let's put it this way. I stick to my way of working, that is, open software is good in the beginning. And if it is an open software which is well developed, like Python, yeah, it's one of the best examples, then you can take it with you in research. But otherwise, if it is just the beginning and you want to do a good research, and if you have funds, of course, available, then I prefer to go to the paid version, because it gives me help, that gives me backup, that gives me a very good tool which I can use faster, and basically my time is well put. And one example which is very good here is COMSOL software. So in other words, I spend my time and the things which I learn at the university, at my PhD, not writing simple software, simple stuff, on the open-based stuff, which is not complete, but rather take a complete software and use my knowledge in a very, very efficient way in order to get very quick, good results.
But on the other side, in the education, it's really it's highly recommended to use also open source software.
For sure. In education, it's something else, and it's very useful for teachers, because there is an unanswered question here. What happens with the children if they don't have supervision? Because probably they will understand very little from that software, especially if they miss the class, for example. And of course, you find places on internet with open software which gives you a class, and you take the class, you do the software, and that's very good. So that's already a level above. But for the most open source software, they are useful under the supervision of a teacher.
Good. Thank you very much, Cristian. It was a great pleasure to have you as a guest. I hope that you get some ideas about how you can use different tools. Yeah, open source is just a solution, not the best one, not the worst one. It's up to you to take decision. I hope that you enjoyed Science Hub. My name is Marian Bănică, and see you soon.